Hello everyone, and thank you for joining us today. So let me welcome you to today's talk brought to you by the Ocean Alliance. My name is Victor Nzembe, a permit engineer for the Ocean Alliance, and I am your host today. I am hosting this course from Lilongwe, Malawi, and I would like to know where you are joining us from. Type in your name and location in the chat. And if you want to receive Ocean Alliance presentations, you can paste your email in the chat as well, so that we can add you to our emailing list. So today we'll continue the sterilization equipment series, and we'll have a talk on large capacity autoclaves. And our presenter today is Engineer Joseph Lugut from Kenya, and he's accompanied on the call by Engineer Daniel Mtama, who is also from Kenya and will be on the call to take any questions that you guys may have. And along the way, there will also be an attendance form that will be dropped in the chat. So I encourage you to just fill out the attendance form and give your feedback on our webinars so that we identify the areas for improvement and meet your expectations. Without wasting much of your time, I'll hand it over to our presenter today, who is none other than Engineer Joseph. Over to you. Okay,
good evening, everyone. I'm Jambo. Okay, it's a nice evening, and I thank all of you for the overwhelming turn-up. As you have heard, Frugut, I'm an engineer here in Kenya and East Africa, supporting free O2 Oxygen Foundation. And but today we are focusing on the series of autoclaves. I know we have had some introductions, but today we are narrowing down to large capacity autoclaves. So I'm happy to be your servant today from here, Kenya, and I believe that we shall flow together to the end. And thank you so much, Lloyd and the team, for the nice organization. Okay, so I've just taken off my screen so that we get a more clearer sound, and also we can have our slides, which I believe all of us are able to see the screen. I have my colleague Daniel, if he can wave wherever he is, Engineer Daniel. Okay, there he is. Yeah, and here I am. So we are all set to go. Thank you. As far as autoclaves are concerned, we all know that in our hospital setup, we have three types that we commonly use. We want to focus today on the largest one. And it's not that we like the largest one, but some time back, we were able to study the small one. And it has helped us in our biomedical engineering. I know about us as biomedical engineers is that we cut across the work, like not just dealing with oxygen, we also deal with equipment that use oxygen. Most of them, they need sterile facilities to administer oxygen. Also, at times, we have distilled water that we also generate from the hospital. So we have the three types that we commonly use: tabletop. We also have an horizontal medium-sized autoclave, and then we have the large automatic autoclave. The large one sometimes may not necessarily be automatic. It is sometimes manual, fully manual, where you use a timer when you have gotten your steam generated to set the goods in the sterilization chamber and open manually. Others, you have semi-automatic. You have to intervene at some stages as an operator. And others are fully automatic. Once you set up a formula, you leave it running as long as there's electricity supply, and they are programmable, and they are also adjustable to the standards that are required. Most of them, again, are sliding door because of their huge capacity in cubic meters. So An autoclave like this, we consider large capacity because it can sterilize goods, maybe that can service maybe even 3 or 4 operating rooms. And so in the terms of operation, it has got power isolation switches. It has got an interface which is programmable, an HMI screen, which shows you a display. And when this display comes on, you can either select automatic mode or manual and pick up the pre-selected or preset cycles. Once you do that, sometimes the interface provides for you to intervene in a program if there is a problem or if you want a change for some reason. Again, there is a printer or a graphical display that gives the monitors the temperatures and also monitors whether there are doors which are opening or closing. So once you are ready for that, you can load and then you can close the door. Sometimes the door closing is automatic, sometimes it is manual, or also semi-automatic. So once you do that, you can run the cycle, and once the cycle is complete, there is always audio and visual communication of green lights or some beeping sounds. So you are, as per the operator's guide, which vary across the models, you are allowed maybe to wait 3 or so or 5 minutes before you open the door. Here you strictly follow the instructions in the operating manual. So in a sterilization cycle, it's gonna be beyond the cycles that we have in the small tabletop. Why? Is because the amount of air inside the chamber is usually a lot of volume amount, and you don't need air in a sterilization chamber. It is a very, very poor conductor of heat. So the flushing that you normally do in the small chambers, small autoclaves, cannot be achieved to get rid of the air. So you have to have a vacuum pump, and so there is always a pre-vacuum cycle. So steam is also takes time to raise it to the temperature and raise steam from water. So there is also a steam cycle. Then the sterilization itself is a length of time that is determined depending on the goods you are sterilizing. And then from there, there is a huge volume of items and some linen. So you might find that steam could have also lost its, the temperature or dryness. Some humidity might have gone in. So you have another cycle just to ensure that everything is fully dry, which that is you suck out anything that has not been released in the chamber, and then you dry the equipment. Once you do that, the vacuum and the pressure is balanced so that the door can open easily. And then you go to the cycle end. So there are many parts in our autoclave, but we are going to touch only on the very crucial parts. Why these parts are crucial is because they really have the interface, or they determine if you are sending a wrong message or you are sending a right message to the equipment. If those are not doing right, then it means that you will either get a wrong signal of a fault or a right signal and you do the right thing. So there is an electronic display board, and it usually has all the buttons for start, stop, and all the cycles that we have seen in the previous slide. Then it also gives other displays that you may not have mentioned: the temperature, the pressure in the boiler, and also in the sterilization chamber, and also the pressure, the vacuum power that you are using to evacuate the chamber. There are pneumatic valves in this autoclaves. Why? Is because you have to open a certain valves at the right time, and these are high pressure, so they may not simply be a valve that you want to operate using maybe bare hands, because there's a very, very high temperature steam moving from one part to another. And then valves, which are manual, and then a printer which monitors or records the cycle temperatures. Again, we also have other parts that are important. Look at the sterilization chamber. It's a huge one. And on a light note, sometimes they are big enough for some of us to fit in. So some of these things are chambers are very big. There is a door gasket, a very, very important component of sterilization. And it is also an important part because you have to close a chamber after loading, and the pressure must be maintained in that chamber. So it's a very important gasket if you know the characteristics and also know the type of material that is used to make the gasket, silicone and beyond. Observe very, very closely so that you are not, exposing pressure to a wrong part of the autoclave if this is a manually operated one. And then a pressure transducer. If you find that your pressures are not recording well, it is good to know how the pressure transducers work so that you can, check on them, whether electrically or pneumatically. More items that usually needs to be looked at are door valves. The door cannot just simply be closed. If it is automatic, you don't have maybe a knob to rotate. You have a valve that is like a latch, and so it is pneumatically controlled. So there are so many pressure linkages that keeps opening and closing pressure. We have pressure pipes which carry signals of what is being transmitted to where at what time. And it's also good to know the pressure switches. When the pressure reaches a certain value, there is always a pressure switch, and these are the ones which are also adjustable mechanically for safety purposes. And then a pressure regulator. Then we realize that we have a vacuum cycle or a pre-vacuum, and you need a vacuum pump that is very robust. And also, if you need the pneumatic valves for closing and opening some of the switches, you also need a compressor. So here again, inside here, you can have a manual bypass valves that may be operated in a semi-automatic, or in an emergency moments, you may be asked to switch off a certain valve manually. But again, you can see the pressure valves are also there, and they can be set to the range that the manufacturer recommends. Electronically, we have so many interfaces apart from the programmable logical controller, whereby all the information is stored. And we had seen earlier there is a CMOS battery that keeps the record of the programs that you program, and also keeps the history of errors, history of faults that occur when the machine is in a cycle, so that if it stops, you can easily come and read in that electronic module that we saw earlier. Digital, why? Because the display is digital, so they have to be converted. Sorry for that. Maybe each of us can mute our mics for now. Then there is main power supply board. You realize that during the troubleshooting, if you find that components are not working well, it is good to know if the power supply is stable. And because these equipments are sensitive to power, we have a phase failure relay that is inbuilt, and it is good to know that it plays a role in protecting the major parts of the autoclave. We also have breakers, which are controlling or preventing any overload in any part of the autoclave. There are those which just watch the control panel, those which watch the heaters, and also those which watch the vacuum pump and all the feed pump, which is pumping water to the boiler. And so it's good to know that they are well arranged and labeled in the electronic panel. The relays, which have so many different functions, are also in a relay card. There are relays there which open the door, which also close the door. So you may look for a knob in some of these autoclaves that you don't find because they are fully electronic type. So when it comes to the big elements, there are some of the heater elements have been labeled here or have been shown for your easy conception, and piping and also water level sensors. You realize these are very, very crucial items in the safety of the autoclave, how they look like and where they are located in an autoclave. So if you find that, again, the boiler, since it is heating and boiling water, you want to minimize heat losses. So usually it's covered by fiberglass type of wrapping material and covered with also metal sheets so that you have enough you protect your heat and maintain the temperature of your steam. So common problems, just generally overview is you come across in an autoclave, and you may or may have them in your technical manual, maintenance manual. There could be power failure. Maybe someone has falsely operated the power emergency button. If the autoclave is getting voltages which are below the ratings and the wrong phase sequence, so the electronics can also be faulty. If you have so many power blackouts or ups and downs, or we call them surges, the contactors, because of their making and on and off many times in a cycle, they could be arced. They could have arcing, and makes the transmission of current, weaker than it should be. So main circuit boards can also be faulty. MCCBs, the breakers can also be faulty. If a water controller level sensor is not sensing well, or it is coated with rust, it can also misbehave. And if your printer for monitoring the temperature is also not working well, you will have a problem. So these are just the common things that you can come across when operating such a large type of large-scale autoclave. Others that can happen because of wear and tear. The equipments are made from materials of certain standards. So sometimes the insulation can wear out, so you have electrical leakages. If pipe joints, threads get rusted, or they get maybe through vibration, you can get water leakages, steam leakages, or air leakages. You can have the latch for the door, which is usually a mechanical movement. The solenoid and the plunger sometimes could be stuck. The gasket, because of many times of you open and close, can get worn out and compromise the pressure in the chamber. And then pressure pipes can also get worn out through maybe even natural corrosion. And so it is good to watch on them. It's just a diagram of areas where you can easily see any type of faults that I mentioned above. Some of the reliever or breathers, sometimes you see vapor coming out from those relievers. So you realize that that could be a problem of some leakage in the system. So again, when you have large autoclaves, you also have large elements. The heater elements could be, they rise in temperature and they also drop in temperature. So you realize that water sometimes is supposed to be well treated before entering the autoclave, but you may not eliminate all the chemical elements. So you might find that fluorine remains in the water and others. So you get the elements, since they heat very high, they can also have some chemical reactions and start wearing out the coating of the heating elements. So some of these are not strange when you see such a heating element being removed from your autoclave. Steam traps, maybe you get a lot of linen being blown during when you are actually maybe releasing the steam, or when you are releasing the water which is trapped. There's linen which gets trapped in the steam traps and cause leakage of those strainers. And electric heating elements, sometimes one may break if they are three-phase, and the other two may operate. So you find that the one which has broken is causing some electrical leakages. So it is also good during your inspection to look at the electrical elements. Now, if the water level sensors are not working well, you will know that you will have maybe too much water in the boiler and takes longer to attain the steam level and slow heating. So, and then again, if the pressure gauges are wrong, you could be waiting for the pressure to attain, but because the gauge is faulty, you realize that you are waiting longer than you should be waiting for. So it's good to check every functionality of those areas that you should look out for all the time. Now, in troubleshooting or looking at the problems, I may not explain all of them, but we have just summarized a chart of, what are the probable cause of problems that you come across in autoclaves, and what are their proposed solutions. This may not be the perfect, book, but it is common. So the sterilization indicator does not indicate the successful end of the sterilization cycle. Of course, the machines are programmed to make sure everything is sterilized. So if something has not been attained, it will not cheat, it will not lie. So what can cause that? The chamber may be incorrectly loaded or overloaded, so steam is not circulating well. Vapor trap is defective, so it's releasing vapor to the air. You find vapor at the back of the autoclave just going up into the atmosphere. And the sterilization time is insufficient. Maybe you put to 15 minutes, maybe instead of 21, and so forth. The vapor does not penetrate to the equipment. So again, the sensors will not cheat you that there is enough penetration. And then there was not enough vacuuming, so there is still air in the chamber, and then the biological indicator is not the right one. So maybe you buy your biological indicators and you put them in there, and they are not the ones which were designed for that type of cycle. So it's good to know through the manufacturer which type of indicator should you use. So solution is simple, just check the load distribution. Most of the autoclaves have racks. So maybe you should try to make the racks equal, maybe packs, maybe 5 packs per rack. And that is a physical skill. Check the vapor traps for any debris that may be deposited there. And the time. Program the right time. When you tell a computer to save the time for a cycle, it will save what you program. So try to follow the set times for the right equipment. So again, the quantities of packets to be sterilized. There is a guide on how much you should load in every cycle. And then when you have any problem, you can also call a specialized technician to clean up the system. And then you will have your running very smooth. For biological indicators, I'm sure the sterilization profession will guide us on which ones to pick. Another problem again that comes is the sterilization cycle keeps breaking or gets interrupted. Well, what could you do? You realize that it could be inadequate vapor or steam or water or air pressure. So maybe in the cycle halfway, the door pressure for the door lock is compromised. So for safety purposes, the sterilization has to stop until you sort it out. So those are the things that keep coming. The material that you sterilize comes out damp. I know most of us have been called up to attend such situations. So there is a vapor trap, and that is a very, very important part of the autoclave to be checking all the time. Sterilization chamber drainage is blocked. The autoclave is overloaded again, as we did say earlier. And then the leveling. This leveling is an issue too, because the water sensors and other sensors depend on the leveling of the chamber. So it will give a wrong signal. So you have too little water or too little or too much water in the boiler. So check the trap, and if not able to clean it, then you substitute it. If you have a drainage system that is a blow down sections, then again check on that. Reduce the load quantity in the chamber to the level and level the autoclave. So it is very important to know that if there is no spaces between the packs, the steam penetration is compromised. Maybe another one that we come across again is pressure is too low. So what can cause the loss of pressure? It is a door gasket that is defective, and then internal vapor leaks into another autoclave component. We have a pump, we have pumps in the system, we have the exhausts and all that. So you find that the vapor is going all the way to the other chambers when it's not supposed to go there. So check the gaskets, check the valves, that is the solenoid valves, and then the steam trap that we have talked about. If you also have excess pressure, okay, your autoclave, you set up maybe some pressure, maybe let's say 30, 40, or even a higher PSI, if you are using PSI, and you are always getting your reading or the gauge being higher. So it means that there is a sensor that is being, compromised. It cannot sense the right pressure. So it is still urging the autoclave to boil more paper. So what could be the problem is that you are overloading with a lot of textile material, and your autoclave is not calibrated. In other words, your vapor pressure reading gauges should match with the reading with the set pressure switches. So first of all, you calibrate, and then the other one, you reduce the autoclave load again. Biological indicators. So suppose this one comes out positive, and maybe you find that everything else is okay. So maybe you made a wrong selection, or that could be one of the measures. So you really follow the manufacturer's recommendation. So for there, we can have a cup of water, and back to studio for some questions and urgent or pressing questions on so far where we have reached. Thank you.
All right. Thank you, Engineer Joseph, for the wonderful part of the presentation. So I just want to take this opportunity to remind everyone that the Oxygen Alliance developed the VM on that. So this is an Android application designed specifically to help engineers have an increased access to medical equipment resources. So additionally, on the platform, you can also interact with all experts from different countries. Yeah, so a link to the application will also be shared as we go along so that you can actually download this application. So at this moment in time, I will allow time for 2 questions. So I will take 2 questions. So if you have a question, you can just raise up your hand, and I will give you an opportunity to unmute yourself and speak, or you can just paste it in the chat.
Welcome, Daniel.
Thank you. Thank you, Joseph, and the participants. And thank you, Lloyd, for welcoming me for this training again. Thank you. In the calibration, normally we can use the indicators. We can also use the autoclaving tapes. The indicators will be able to show whether the autoclave is working perfectly or not. The autoclaving tape also can also be the change of color from the white strips to black strips. That will also tell us if the autoclave is achieving the correct temperatures and pressure. If it is achieving the correct temperature and pressure, if it is 104 degrees, the autoclaving tape will be able to change. In the case of the pressure gauges, you can attach another pressure gauge where you have the pressure temperature gauge and find out that if the working pressure gauge is reaching at 2.2 bars, the pressure gauge you have attached, is it also reaching at 2.2 bars? And the most important with the autoclave is pressure temperature relationship. Without achieving that pressure temperature readings, you will not be able to achieve the sterilization. Also, if you are evacuating to either -1 or you are evacuating up to -0.7 of bar, you need to attach another gauge to see if the machine gauge is reaching at -0.7. The attached gauge, is it also reaching at -0.7? That will be able to show us that your autoclave is working as required readings. I don't know whether my colleague engineer also can add other information.
All right. Thank you, Engineer Daniel, for that answer. I hope it answered the question. So I will take the last question for this part. There is a question from Gideon. He's asking, the autoclave is taking too much time to achieve the temperature. So I suppose you want to ask what would be the problem if the autoclave is taking too much time to achieve the temperature.
Yeah, thank you for that question. Am I audible?
Yes, go ahead.
Thank you. Thank you. If the autoclave is taking too long to heat, one you need to find out are your electric heating elements, immersion type. Are they receiving the correct voltage? No, load, if we can go back to the display picture, you can see these are the phases, line 1, line 2, line 3. If the correct voltages are attained, that is 415 volts, this light has to be on, this light has to be on, this light has to be on. In case you find the intensity of this light is low, and these two lights are, the intensity of this light, it's okay. This one and this one is okay. But if you find the first light, the intensity light is low, it means the voltage here, the voltage for this light is less. If it is less, it means our electric heating elements, they are not receiving the correct voltage. And that means the heating will be slow. Number 2, there could be some leakages of steam. So if there are any presence of leakage of steam, it means you will not achieve the set pressure and temperature, and your autoclave will take a longer period of time. Number 3, if your electric heating element, all the generating chamber is dirty, it means that mud, that dirt has enclosed the electric heating element. So the heat has been prevented by the mud. So after every 6 months, the engineer is supposed to clean the generating chamber. He is supposed to descale the electric heating element. In case of that mud and that formation of scaling within the electric heating elements, if that formation is there, then you will find that there is low heating. And that low heating, it means your autoclaving time will take long, and the heat provision will be low. So after every 6 months, the engineer is supposed to clean the generating chamber. In case, as the engineer had said, the immersion type of an element is faulty. Let's say the unit is diode. Can we go to the generating chamber down? These two are the set of electric heating elements. This one and this one is a set of electric heating elements. This is one set. This one set contains 3 elements. There is this one. This will go inside, then make a U. This is one set. This another set. Then this the third set, this one here. In case one of these electric heating element is faulty and these two are working okay, then you will find that the heating time takes less. So as an engineer, you need to disconnect the terminations, switch off the unit, and using the resistance range, using the multimeter, set the resistance range and measure the resistance of these elements. We are expecting you to get like 80 ohms, 60 ohms when you measure between this line and this line. In the resistance has to be in ohms. But if you find this is measuring 80 ohms, this is measuring 80 ohms, this one is measuring maybe 200 ohms, more than these two, it means this element has a problem and this one has to be replaced. So what we mean here, for you to be able to get the right amount of heat, this set and this set, all the electric heating elements must be providing the correct heat.
All right. Thank you, Engineer Daniel. I can see a hand from Engineer Joseph. So if you have anything to add, you can actually add, and then you can proceed with the presentation.
Okay, thank you. Yes, I was concerned that my colleague was pointing at the elements, and then they were not His cursor was not being seen on the shared screen. So, but my colleagues, we have understood the answer about the issue of low pressure not being achieved, and then too much time. But now there is two things that we will answer the other two questions at the end. One is what do we use to clean? We shall share with you that, and then the one about the cursor, we shall in the next answer section we shall take the cursor to the screen. So now about the water for CSSD. One thing that we need to know is that we just don't use water from the tap or from the boreholes or just untreated water. Water is there is a grade of water that is specified for every autoclave, and so we ensure that I can see you have proposed RO, but Amos, and not necessarily RO, but deionized water if possible. But we know very well that many people don't get access to deionized water. Also some people don't get access to distilled water, but to ask for the list is to ask for distilled water. That is what we recommend. So the other two questions about what we use to scale, and then the other one about matching the pressure and temperature.
Hello, Engineer Joseph. So take the other questions at the end of the presentation. I will take notes for the questions, and then I will read them out to you. So you can actually just proceed with the presentation.
Okay. Yeah, they will be answered along the way. Thank you so much, Daniel and the team. So we can now move to our second part, preventive maintenance. We shall look at the preventive maintenance and then the routine quality assurance. So we just have something there to show you what routine maintenance can do. When you have a sterilization chamber, the filters you remove and you clean them, and you will always see something depositing there. I mean, there is no day you will say that I've been using good water. You know, when you boil substances, you must get a residue somewhere. So you clean the chamber using cleaning products that do not contain chlorine, and we also use with an acidified solution. Usually in the manual, there's provided even the percentages of the solution that you use to clean the chambers. Again, you are not restricted to using water, so you can use plenty of water to rinse the system. The external part is usually just use any solvent that is mild, and clean the external part without deleting or removing the writings that are usually on the external part. So if those are manually activated, it is good to look that they are well adjusted and they operate smoothly. That is, the latch locks and opens. When the vapor is being released to the atmosphere after a cycle, so most of the time it is good to check that it is doing its work well. It is clean. There's nothing that can cause it not to close back well, or that can cause it not to seal back after opening. Never use steel wool for cleaning the inside of this chamber. And then check for adequate functioning using a biological or chemical indicator to check the temperature. Use chemical test strips, checking time and temperature of exposure, solved for this purpose. So before you go to the biological indicator, there are other materials that you can use for cleaning the walls of the chamber, like a scotching pad and others that are not necessarily steel wool. We know steel wool is a material that breaks, brittles, and leaves a lot of pieces that can cause blockages. Filters and strainers, Sometimes other countries, they call it strainer. These are the ones that can remove the solid elements when for the water feed lines, which could have compromised the boiling and the creation of steam during the steam generation cycle. The valves that close and open, the release valve and the relief valves, it is good to know that to feel whether they are tensioning well and sitting back in their natural seats. For safety valves, which this is an annual event, it is good to dismount, clean, and adjust, but not without the maintenance manual, please, because every manufacturer usually also has some methods of dismantling. They don't just, they are not all the same. They can be differently mounted. Change the air intake filter. That one should be easy. Conduct a general sterilization process, which we shall describe to you in the next page. It is good to watch the cycle, whether it changes from one state to the other progressively until the end, and then do the quarterly routines. So annual maintenance is a lot of activities. Here we have just highlighted to you the major areas. Like we were told earlier by Engineer Dan that very many things, when you just even open the boiler, if you realize that there is too much of a certain substance, you could easily tell scaling, if there's too much scaling, it means you have a lot of assignments to do in your feed water. If there is soil or earth deposits, there is something you need to do with your filtration. So it's not just listed here, but there are so many other things that you verify. You look at even the cables, connectors, if they are starting to brown up or harden because of overcurrent, those are also visually checked and for safety. Now, safety is a very huge area again in autoclaves, and it can cause injury to the operators. So it is good to have a very follow the instructions carefully, and also it demands in some situations to wear PPE. It doesn't. Sometimes you have autoclaves that you are not required to operate without hand gloves or without eye goggles. Some of these situations I've seen in some places. Some people have also built an into the wall autoclave. That is so that the operator side is not exposed to the hazards that could occur if there is a problem in the main autoclave. So when you want to have the users use the device, do thorough testing and verification before you hand it over. So if you also want to hand it over to the users, make sure you have checked the gaskets and check for scaling as we have been told, and you can remove that scale or that whenever you see it. If there is a gasket or if the gasket has broken, this can be very, very dangerous. Some of us wants to use some silicone glue and all that. Those things are never advisable. The most advisable thing is to replace the gasket. Then, if the temperature in the vessel during the when it is during the cycle of sterilization, it is good to do other even non-loaded tests so that you know very well that it attains, even without loading, it attains the temperature that you want. Safety valves are very, very crucial. You can even sometimes find safety valves that have been adjusted and a padlock placed on them. Sometimes they are small miniature like this. So it is good to test again according to the maintenance manual or technical manual. Don't try to test it using just your own expectation. So they are normally set, for example, to 30 psi. And so if you pull the plug and there is steam in the jacket, you will hear the steam going out with some bang sound. So it is good to know what you are doing at that time. Maybe you're just checking the operation, the safety of the system. So you don't do it if it was not during a scheduled maintenance. Again, perform a quality assurance performance. Just verifying or validating that the cycle is usually complete and it has done its job. One is sterilization indicator mark. So it darkens when the bag and its contents have been adequately processed. There are also indicators that are called biological, and it also ensures that it has reached the correct temperature and time. Chemical indicators on the medical packaging and autoclaves, they change the color. So at least all of us, again, also have seen this method being used to verify the sterilization process. So it just shows that it has completed the cycle. So just also learn to read the instructions of any item that you use to verify your sterilization system. Another one for us engineers is to verify a full cycle. We call it Bowie and Dick device. You place it at the center of the stack of paper. So it is supposed to prove that the process has achieved full temperature and time and adequate penetration. So you run the cycle at 274 degrees Fahrenheit for 3.5 to 4 minutes. So to prove sterility, the biological indicators are used. And this one we have mentioned several times. So that is the end of our sharing today. I know we have touched, it's like the tip of the iceberg, but I believe it has given you some hints and insights on these large-scale autoclaves and what you can do with them to make them reliable and make them safe, and also make them work during your time when you are managing an autoclave as CSSD. Thank you. Back to you, Victor.
All right. Thank you, Engineer Joseph, for that wonderful presentation. So I will be taking questions. Actually, I will also take the questions that were asked in the first part of the presentation as well. But before that, I just want to remind our audience that an attendance form has been posted in the chat. So I just encourage you to fill out the attendance form so that you can have your feedback, because it helps us identify areas for improvement and reach your expectations. So firstly, I will check the questions that were placed in the chat, pasted in the chat area. So our engineers, you can take them. So the first question was from Mark, who was asking, what can cause a mismatch of temperature and pressure during sterilization? So I will just read two questions so that you might take both of them at once. And the other question was from Richard. He was asking, what chemical is used in descaling the elements and how is it done? So our engineers, you can just take those questions. Thank you.
Okay, allow me to go first, and then I will request Daniel to end. I would like to talk about calibration, and we will not go into the details of calibration of temperature and pressure. I know all of us know that it's not a walk in the park, but there is, the manufacturers have made some, validation processes a bit simpler. I mean, they will allow, this is a high pressure system, and you cannot say you are going to have an invasive point where you will place your thermometer and all that. So I think you will have to follow the manufacturer's validation method. For example, I'm sure there will be a points where you are allowed to attach a pressure gauge and verify that the current pressure gauge is correct, where you'll be attaching also a pyrometer for temperature, so that you can also verify the temperatures are being reached. But outside that method, that is another different procedure. There are validation cycles that the manufacturers give you to run maybe every day in the morning or once a week, and those are usually called validation or performance confirmation type of calibration. So if you follow any of them and you find that one is off, the maintenance or the technical manual provides you with sections in the programmable module or in the circuit panel that we showed you where to adjust and make the temperatures equal. So the other one about cleaning, we have so many options as long as they are not chlorinated. For descaling, we use mild descaling agents. It is very hard to mention a name right now, but I know in the market we can, and even the manufacturer are put it in their manuals, maybe particular choices of a little bit acidic solution that you can use. At this moment, I cannot give you a name. And then let me answer one more question before that about the water. I mean, what causes the water level to go down? This is now a chain of events. If you have a leakage in the system, then your boiler will work extra hard to boil water to replace the lost pressure. So if the valve for opening and pumping water to the boiler is not responding fast enough as much as the boiling is going on, you will have a low water level sensor. And we have seen other issues in this presentation where maybe the leveling of the autoclave is not right, and also the water sensor itself is malfunctioning. And then one other thing that people forget about the autoclave is that there's the sensors, any equipment that has electronic sensors, they have to have very powerful and very, very strong earthing. So if your earthing for the autoclave is weak, the sensors depend highly on the flow of current to generate a signal of the water level. So if there is that flow of current that is not being allowed to reach the threshold because of poor earthing, then there will be a lot of errors being displayed often in your screen. Thank you so much. I hope I've addressed your 3 questions. Over to Daniel to complete the other questions.
Yes. Before you move to the other questions, I have a single question which I posted it in the chat, but I'd like you to say it out loud. Locally, what I've seen, people use white vinegar for cleaning and descaling. Is it right, or and if it is wrong, what other maybe fluid or liquid can we use for descaling? Thank you.
Yes, Engineer Daniel, you can go ahead.
Thank you, Leon. When you are descaling the element, you can use acetic acid. And before you use the acetic acid, make sure the water in the generating chamber is warm. Then after that, you put acetic acid, allow the solution to settle like 20 minutes, and then you can empty it and now try to clean out the scaling. If you find that the scaling has not come out completely, you can still repeat and remove the remaining scaling. There before, we were using nitric acid in the ratio with the water. We were using in the ratio of 1:10, but this should not be a very strong solution. It has to be, the solution has to be mild, and you should not leave it for long. That can take less than around 7 minutes, after which you drain the solution, and then now you clean out the scaling.
All right. Thank you, Engineer Daniel, for that response. I hope it answers the question. So I will just take one last question that has been posted in the chat, and then we'll close off. So the question is from Japheth. He's asking, how do we calibrate a safety valve? So our engineers, you can just take that and then we'll close the question.
Okay, sorry, I think the question has been overtaken by some conversation.
All right. I was asked,
The last question.
There is
Yeah.
a question from Japheth. He's asking, how do we calibrate the safety valve?
Okay.
I hope you get that.
Okay. So thank you, Japheth. Today we have actually addressed the checking and the maintenance. For safety valve calibration, it will have to be done in a calibration lab. Why do I say so? Is because it is either you have a calibrated gauge that you can attach to the system, and your autoclave will not go to the your autoclave will not go to the overload pressure naturally without disabling other features. So you may not attain the 30 psi on your autoclave to cause it to open. So I believe either at the manufacturers or at the calibration lab, if there is one near you. But checking whether it operates before 30 psi is possible for you, because as long as it has not taken off, then that it means it is within the safe area. So for us in maintenance, we only check whether it is opening and closing smoothly. In case of an overpressure, it will not be stuck. Okay, I hope I've answered you, Japheth. Okay.
Right. Thank you, Engineer Joseph. So with that, I just want to remind everyone to fill out the attendance form, as it will help us to know who attended our webinars in issuing of the certificate of attendance. So just fill out the form and give your feedback. So with that, I want to thank everyone for joining us. And if you have questions or comments, please email us at info@optionalliance.org. And for any technical questions, you can also email us at helpdesk@optionalliance.org. And your questions and concerns will be addressed accordingly. Thank you and have a good evening.